Hello, ElixirConf. Our next talk is presented by Stephen Bussey, and it is called The Joy of an Elixir Monolith. Stephen, the broadcast now belongs to you.
Hey everyone, thanks for tuning into my talk today. As Anna said, the joys of an Elixir monolith is the talk. Real quick about me, I'm a software architect at SalesLoft, and I'm actually bootstrapping a side company as well called Clove. And I've been using Elixir since 2016. I have published a book with pragmatic programmers. It's now out called Real-Time Phoenix, Build Highly Scalable Systems with Channels. You can see the link there at the bottom. So I want to set some expectations for this talk. At SalesLoft, we have what I would consider a Ruby monolith core with microservices for new things. And I've spent a lot of time thinking about how I'll build and structure the next app, which is what I'm working on right now with Clove. So the goals of today's talk, I'm not trying to convince you for a monolith or microservices. There's a lot of material out there, and that's not really the goal of what I'm trying to do. I think that saying do X or do Y without understanding the specific needs that you have is probably not super productive, so I'm also not going to do anything like that. I will be highlighting features of the Beam that make Elixir and Beam languages excellent for monolithic applications. And we'll focus on social and technical aspects of monoliths and microservices. So what are some reasons that microservices became popular? I think that we should start at this foundation in order to evaluate monoliths. So I think that there's two main aspects to consider. The first is social. So a great example of this is the decoupling of teams that don't directly work together. So imagine that you have an engineering org with 20 engineering teams, and they're all working on different parts of the app. With microservices, it became popular to decouple so that they wouldn't have dependencies on each other directly unless they needed to interface. And then with a microservice architecture, we can isolate rates of code change. So we might have a part of our code that never really changes. And that could be in a microservice that really isn't touched that much other than security updates. And then we have another part that's being hit all the time by lots of different teams, and we can have different sort of protocols socially in place for how to deal with those repos. And finally, what I think is the most important one is that teams can choose their own language and play around with new things. So we would, at SalesLoft, would not be using Elixir without having the ability to run microservices, because we wouldn't have been able to try Elixir off of our Rails monolith. So the other reason is technical reasons. So these are ones that we often talk about, like isolation of deployment. So we want to have separate scalability stories for different types of our application or different sub apps. Isolations of faults is really important too. So imagine that you have a service that's misbehaving and is down, that doesn't affect other services in the microservice architecture. And then also there's full data and request isolation, which can help reduce performance problems. So coming from the Ruby world, and I'll share a little bit about this, it can be common to have a request that affects another request, even if they're not related, because they're running on top of the same runtime. And I think that Elixir is well positioned to solve many of these problems that microservices solved historically while still having the monolithic application. So the first thing I'll be talking about is the joy of incremental change. And really, I think this is an important part of growing an application, which is slowly increasing the complexity over time. So no application is going to start out with a large amount of complexity, or maybe I would say no successful application. We start small, we build, things change over time, we learn new things, and things grow. So as you develop that application, you should be thinking about and looking for ways to make change easier over time. And good design is often language agnostic. So we might have some practices that we talk about in the Elixir community that really don't have anything to do with Elixir. They're just enabled, or they're first class in the Elixir community. So I'm going to use the word here, and I hear about a lot, context, right? So I think it's important to consider what is a context. And when I use the word context, what I mean is an organization structure for grouping similar domains in your application. It's not really, I don't consider it domain-driven design unless you're specifically doing that. They're not inherently the same thing. And really what a context to me is a module and sub-module organization structure with additional rules about how your functions are accessed. In particular, that your public functions are at that top level module and you're not using these submodules in the rest of your application. So code with context, we can develop a code structure over time. So I think that a good start for pretty much any application now is to start with contexts that maybe even just have functions directly defined in them. So that, you could imagine a context where you create a comment and you actually have your repo call right there in that top level context. But as you grow the code base, you want to look for ways to incrementally change that code. So maybe depending on, if the application grows and is successful and that part of the application grows, you can refactor that to context and delegate to other modules, submodules, so that you're sort of bridging out where the code actually lives. Maybe then over time, you can refactor by combining or pulling apart context, because honestly, we're probably not going to get our context right from the very beginning because we can't anticipate what the future is going to be. And then maybe we can abstract or extract our Elixir applications underneath an umbrella over time as well. And starting with top level context gives you some pretty good social benefits in terms of building a monolithic app, which is that you're grouping similar functionality under the same module. That's a good thing. And don't worry if you get the context wrong, because you can always change and adjust them over time. One thing I think that, being functional oriented language like Elixir is, I've personally found it easier to do refactorings because I can move a module around and shift it around versus, in my OO languages, when I'm doing refactoring, I have to often think a lot about what the object graph is like, if there's any inheritance, and those things can be a little bit tricky. And also don't worry about occasionally breaking the rules. I break the rules in my app as I need to. If I have a performance reason and I don't want to just be pure to the context, I might break that rule a little bit. Umbrella projects have a mixed reception in the community. I think the important thing here is that you can grow into it over time as you want or need it. These can help decouple development and testing between teams, which brings pretty significant social benefits. And this would be something that, historically people that have a monolith might say, well, I need to start doing microservices. But with umbrellas, we might instead say, well, maybe I need to have a new sub application underneath that umbrella, and I have isolation that way. So we can sort of get some of these benefits that microservice historically brought us. So next, I'm going to talk about the joy of a compiled language. We can take advantage of Elixir's compiler to help enforce, technically, our social needs. So an example of this is I think it was in 1.10, compiler tracing came out. And essentially, these are functions that are executed during compilation. And you can write these to help provide additional validation or enforcement. And this can be a technical solution to a social problem, which I think is an important part of growing the code base, a monolithic code base over time. And a great example of this is the boundary library by Sasha Jurek. This is still a pre-release library, but I think it shows a lot of promise and gets to the heart of what I'm talking about. It uses the compiler to enforce defined boundaries between modules and their submodules. And this is a technical solution to a social problem. Having the ability to do this in a language is crucial as the code base grows. Because if you don't have the ability to do it, you start wondering, well, is there any way to do this? The only way I can see to do it is maybe to start doing microservices. So up next, I'm going to talk about the joy of parallelism. So the Beam itself, the Beam runtime, brings technical capabilities that are very beneficial for monolithic apps. So an example of this is the compute parallelism, it's a hard word to say, that the Beam brings. So you can use as many cores as you have available. You can actually change this to whatever you want. So you could actually technically have more schedulers than you have cores available. That wouldn't really be a good thing. Or you can even have less depending on what your specific application needs are. And parallelism is going to happen at the process level, which is perfect for web apps and background tasks. So if you can imagine that every single request is a process, or maybe every background task that's executing is a process, these are going to be isolated from each other, and they're going to be able to execute in parallel with each other. And if a monolithic Elixir app, or really Beam app in general, is having performance problems, you're almost guaranteed to speed up by increasing the machine size. For exactly that reason, if you had, 100 requests per second coming in and you double the number of cores you have, you can execute twice as many in parallel. Now you have other things like your database layer and other APIs that you might be working with that may struggle with that, but this is something that you can do on the Beam, and so you have options here. So an example, if you aren't familiar with the schedulers that I just mentioned, what the Beam does is you have a series of schedulers that by default is the number of cores on your machine. So like my MacBook, when I boot it up, it has 8 schedulers because I have 4 cores, hyper-threaded 8. So each scheduler has a run queue. And you can think of this as sort of a process with a given function that's executing, and it's just waiting in line to execute. And let's say that you had, they're sort of a best guess at load balancing these things internally, but you had something that was, really slow and is bogging down a scheduler. There's actually some migration logic in there to move it around, so you get this efficiency. And as an example here, if you have an expensive CPU serialization that's going on, it's not you're not waiting for the database or anything, you're actually doing something with the CPU on scheduler 1. Well, if you have a request on scheduler N, that's going to be completely unaffected. So if you can have multiple CPU serializations in progress at the same time. This is something that sort of kicks my butt sometimes in Ruby because of the global interpreter lock. I'll have a CPU heavy task that actually sort of locks up the entire set of requests on this on the node that I'm on. The other thing that's awesome about the Beam is preemptive multitasking. So if you have a CPU heavy area of code, which isn't honestly super common in web apps, I think it's most common for JSON serialization, or HTML sanitization is pretty expensive, or data marshaling in and out of a database. Those are things that are going to be CPU heavy. So you want to make sure that those things aren't going to lock up the entire app. So an example of this from a social perspective is if another team ships out inefficient code. They ship out an endpoint that serializes, 100 megabytes of data, and that's going to just take a while on the CPU. If there's an incident with that, the chance that there's going to be a system-wide meltdown is significantly reduced because of this preemptive multitasking. For me, this is one of my favorite things about the Beam. So if you aren't familiar with this, I'd say look this up a little bit and read some about it, just because it is really interesting stuff. The other thing that I actually do think is really interesting, but we don't talk about very often, is the Beam's garbage collection. And I say we don't talk about it very often. We pretty much only talk about it if it's ever a problem. The Beam does garbage collection pretty much largely on a per process level. There is a global garbage collection as well, but it's most likely what you're going to be hitting is per process garbage collection. So if we have a process that's doing a lot of allocations for its data, we're not going to end up with global GC pauses that's going to affect the CPU of other requests. So this is a pretty cool feature as well. I'm honestly not familiar with a ton of other languages that have this particular feature. It's really neat. So the other thing that I want to talk about is the actor model. The actor model lets us compose our application of many sub-applications very easily. So we can think of this like composing subsystems, sort of like we might do in a microservice architecture. With the Beam, we can construct our application of other applications, of supervisors, of processes. Everything's really a process at the end of the day, but we're building this application based on this tree. That's what's called the supervision tree, or even maybe application supervision tree if we're looking at multiple applications. So the cool thing about this is that we can really easily add like in-memory processes or data structures that have unique life cycles, and we can do this really easily. So I'll give you an example of this is we were adding an in-memory cache to one of our services that had a high throughput. And typically in Ruby, I might just be like, all right, let's use Redis or the database or something like that, and we'll cache it there. But it was cool in Elixir, we could really easily add an in-memory cache and then have some coordination between our nodes to make sure that they are somewhat in sync with each other. We didn't need perfection here. And we had unique life cycles, like I want to clean this key of data after 15 minutes. And I can schedule that, and I don't have to think about the rest of the application at all. I can focus purely on the system I'm working on. I'm purely thinking about my cache right now. I don't have to worry about how it's going to affect other things. This is, I think, fairly unique to the Beam. I know that there are other languages that have, I should say, other runtimes that allow this type of async code, but the way that it's thought about with the Beam, I think, is really coherent and is good as something that you can grow into as your needs evolve and your application evolves. The other thing that a lot of people really tout as one of the top things about the Beam is fault isolation. So let's give an example here. Team A owns a performance critical cache process in this monolithic code base. Team B owns a channels API. Doesn't really have anything to do with this particular cache, and it's serving a completely different, end purpose. So team A delivers an update to the cache, and it starts frequently crashing. And we might ask ourselves, what happens? In a language or runtime that didn't have fault isolation, we would probably see the channels API just crashing along with the cache, and our app is basically down fully. But because of the Beam's fault isolation, these are most likely going to be isolated. We can actually make them dependent on each other if we want to, or we can make them fully isolated so that if the cache is crashing, the channels API is still up and serving requests, and everyone's happy with that. And so the important thing here is that we have a choice about how faults affect our system. And again, I think choice is one of the really important things as we grow our code base, because we don't know necessarily what our needs are. We need to have a good choice so that we can evolve appropriately. We could build it, we could build sub applications completely walled off from others if we want to, and have almost like a microservice in the Beam type of architecture. That's not something that I typically would look for, but that is something that's possible. And it depends, again, on the needs of what a particular application has. So process naming, this is another thing that's just, interesting when we think about microservice and monolith. It seems maybe pretty trivial. You can name a process. So let's say I had a cache and it's a process that has a PID, I can name it my cache. And other things in the application can reference my cache instead of PID. In a way, this is a little bit like service discovery. What I really need is the PID so that I can send it a message, but the Beam is going to handle translating the name into the PID automatically for me. And it can even do this across the cluster. You can reference other nodes processes as well. And like I mentioned, you can build out internal APIs completely behind process calls, but not generally something I'd recommend. One thing that Quinn Wilton was just talking about in her talk is that you basically want a serial code flow rather than a parallel code flow. It is easier to think about. So that's something I'll caveat here. So another thing I want to talk about is the joy of continuous improvement. And this is a question that I was sort of thinking about as I was thinking about this talk. Does delivering a monolith at scale require rigorous development practices? And I would answer unequivocally, yes, it absolutely does. An example of this is that your test suite duration has to be kept in check. If you have a bunch of microservices, for example, it might be easy to just say, well, this service, it takes 5 minutes to run these tests. It's not really a big deal. And if every service was like that, it might be fine, but really when you're looking at the holistic picture, you don't have a great testing situation. So delivering a monolith sort of forces you to get testing right. Application configuration has to remain as explicit and simple as possible, because if you're shipping out config changes all the time and it's not clear what those are to the deployments or to other engineers, this can provide social issues. So that's something that, is a good habit that you'd have to get in check. Another thing is that we'd have to avoid global side effects in our code. So, one of the big things I often hear about monolithic apps that sort of transition to microservices was the effect of, accidental global side effects. They change some code or something happens and it affects all of the requests or other requests that are unrelated. So by delivering the monolith successfully, we have to avoid those types of things, which would generally be considered a good practice. And we must have good code organization. If we don't have good code organization, maybe applications separated out, or at least at a minimum, good context defined, other people are not going to be able to use and read our app over time, which is going to sort of evolve into a degradation. So let's not finish this talk without some trade-offs. I always like to include trade-offs in the stuff that I talk about so that I'm not looking like I'm just trying to sell something. So, one thing about Elixir is that we don't have a strong type system. For me, Dialyzer doesn't quite do it. I think it is telling that some of the larger Ruby monoliths are helping push out the type solutions that are upcoming for Ruby. So, if it wasn't important to them, they probably wouldn't be investing significant amount of time and money on those initiatives. And the jury is still out on this. People have opinions. Some people really like dynamic applications, and other people really like the statically typed types of applications. So again, this is one that I leave as sort of up to the reader. The other thing is that we can't experiment with new technology easily. And I think this is the #1 social benefit to microservices. I can't overemphasize how important it is for people, the engineers that are writing code, to be able to have a place to experiment and try new things. That's something that's going to lead to better retention and happiness in the job. And so you can always introduce a separate service as sort of a microservice on the monolith, but there are lots of problems that you have to solve. Operations, observability, data ownership, authentication, consistency. These are things that you have to solve in a microservice strategy that you may not be prepared for if you just have a one-off microservice. And that could lead to failure of the project. And large apps are just hard in either case. Like, monoliths, microservices, if you have a big app and you have the best foundation, it's still hard. Like this is still stuff that takes significant amount of resources and time to get right. And there's lots of challenges you'll hit in a monolith or in a microservice and say, this would be easier with microservices or vice versa. That'll always happen. So wrapping up here, the one thing I want to say that's really important for this talk is to favor pragmatism where possible. So you do want to keep a path open to future change, but don't sweat all the small things. One thing I often see when I hear about contexts is, I don't know where to put this. I don't know how this works out. And that's an example I'd say, don't sweat it, figure out a place for it now and figure out how to evolve over time. And then also using a foundation that won't present a brick wall in the future, which I think the Beam meets that pretty well as a very strong foundation. Because if you want to have a path open to change, you don't want to just eventually hit a technical roadblock where you say, this is not possible, we can't make this change. Finally, the Elixir and Beam give us a foundation for building a successful monolith. And if we're trying to build a successful monolith, as Martin Fowler says, the most successful microservices usually stem from successful monoliths. So we should always, when we're starting something new, be reaching for, I want to build this as a successful monolith, and we can change and evolve over time. And the Beam is a great foundation for that. So thank you everyone for doing the talk. We're going to have some time for Q&A here. My Twitter, if you have any direct comments or questions, is Yoda with 4 O's and 4 A's. The Real-Time Phoenix book is at sal.es/RTP. And I have a fair bit of Elixir posts, some older, some newer, but most still relevant on stephenbussey.com. That's it for me.
Thank you, Steve. Thank you so much.